This is a continuation of threads intro video. Um, so talking about creating threads again. Okay, so say if I were to do thread T is new thread of a job, which is also called a target, right? Now my thread T is in state new, okay, right? And then if I do T dot start, it doesn't move to running state immediately, it moves to runnable state, which is this one here. It moves to this state, in which it is put into a runnable pool, right? And the JVM picks up thread from the runnable pool. Okay. Now, when JVM picks up the thread, it moves it to the running state, right? And based on what code it executes, it could be, the thread could go into waiting state, or it could be blocked, or it could be put to sleep by an instruction within the thread. Now let's take a look at some of the methods which are used to prevent the thread execution, that is, which are used to move the thread from running mode to either runnable or waiting or blocking mode, but not to dead. Okay, so the one method is sleep, which is a static method, and it's kind of misleading because it's usually, okay, one thing to be noticed is one thread cannot affect the state of the other one. So one thread cannot put another thread to sleep. There were a few methods like that before, but they have been deprecated. So a thread can affect its own execution state. So if I have here is a static method thread.sleep, which accepts a long number which represents milliseconds. What's misleading about this is when you say thread T is new thread job and you say T dot start, right, and then if you say T dot sleep, then you might be thinking that you're putting T to sleep, but that's not true. Now, because sleep is a static method, when you do T dot sleep, it would be converted to thread dot sleep. So you're actually putting the current thread to sleep, but not T, right? So the main thread would be put to sleep for 100 milliseconds, but not T, right? So this is like saying, well, you have a main thread which is executing, and you spawn a thread within this thread in which you have thread T. This is the main thread, this is the main method, right? And then so the run method would just be executing fine, but because here there is a sleep, you're actually putting the main thread to sleep, but not this one. Okay, so it's always better that you use thread explicitly, just to avoid the misleading part. So a thread can affect only its own execution state, but not that of others. Okay, let's look at alright, so well, if interrupted in sleep state, an exception is thrown. It's called an interrupted exception. After sleep, a thread goes to runnable state, that is to the pool, but not to the running state immediately. Okay, that's really important. Another method which would affect a thread's execution state is yield. It's also a static method. Thread.yield is the way you would call it. Okay, so just to understand what yield does, we need to talk a little bit about the scheduling scheme, or followed by JVM. So most JVMs use preemptive priority-based scheduling. Okay, now what? Okay, let's take a look at this scenario. You have this runnable pool. You have a new thread which is admitted to the runnable pool. So that's like saying T new has been created. Thread T new is new thread of a target, and then you said T new dot start. So when you said that, T new has been moved to the runnable pool, right? Now say for example there is a thread already running, right? Now the priority of T new is greater than priority of T running. If that is the case, then T running would be sent back to the pool, and T new would be given given the CPU slice, right? So in most cases, that is what JVM follows. It makes it makes sure that the priority of the running thread is greater than or equal to the maximum of all the priorities in the runnable pool, right? So that's like saying the priority of the running thread should be at most the maximum priority of the maximum priority of threads available in the runnable pool, right? Now how do you we can also set thread priority. By default, a thread gets the priority of the thread that creates it, which is right. So or you could do t dot set priority. Now this is an instance method. You need to invoke this on a specific thread, right? If say for example, if right, so by default the priority is 5. Some JVMs might not recognize 10 different values, so even if you say you have 1 to 10 priorities, some JVMs might only recognize 5 of them. So for 9, 10, so these two priorities would be mapped to 1, these two to 2, and to 5, you know. Well, there are some methods which would define priority. Sorry, there are some constants which define certain priorities like this. Also, yield makes a thread to go from running to runnable to give way to other threads of same priority. So that's the functionality of the method yield, but it's not guaranteed that the same thread would be selected again. Sorry, would not be selected again. It's not guaranteed that the same thread would not be selected again, so I could have the same thread selected. So all that yield does is so looking at threads of equal priority, it would try to give a fair chance to threads of equal priority. Now another one is join. It's a non-static method again. When you do say, okay, now here your main method is executing this piece of code, and you do t dot start, and then you do t dot join. So what this means is you're asking the main method to join to the end of t. So the main method to join to the end of t. That is, the main method should wait until the execution of t, right, and join it at the end. Another variant of join is t.join milliseconds. So the main thread would wait for these many milliseconds, x milliseconds, for the completion of t, so that it could join at the end of t. So right, but if t doesn't finish its execution within x milliseconds, then main would just ignore this one and start executing its own code. Thank you.